Okay, because there is, I think, 9 tests you have to know for this unit, I'm just going to try to bundle a couple of them into one video so I'm not making 9 separate videos. So in this video, I'm going to hopefully get through the nth term test, the harmonic series, and the telescoping series. Okay, so the nth term test is a test that you use first. This is the first thing you want to do because it's probably the easiest thing you're going to have to do. And it basically involves a series that looks like this. And once again, I did not race. So, sorry, I'm doing a lot of videos right now, so you may be seeing a lot of me in this green shirt, but let's say you have this series. And as you see, they're going to get more and more complicated throughout the unit. So as of this video, you just know how to do a geometric series, which is just some number taken to the n. Now, of course, this can, by the way, I just want to reiterate, this could be more complicated. For example, you can have, I don't know, something like that. Remember, 1 and 1 to the n are the same thing, so then you'd have to put parentheses around that and do 1 over. My point is that it can be more complicated, but as long as you can simplify to something to the nth power, that's a geometric series. This one, you're going to get so it's not an arithmetic series because you're dividing by n. If it was an arithmetic series, aka it was just like 2n plus 1, it would always diverge because you're always adding the same number. So what are we going to do for this one? Well, you're going to do something called the nth series test. And what this test is basically saying is, in the last one, you could think of the geometric series test almost like the nth term test as well. And basically, we know that 1/2 to the n, if we'll take a series from n equals 0 to infinity, we know that's going to converge because r is in between -1 and 1. But another way we know that is that if we expanded this, and it'd be 1 over 2 to the n, because 1 to the n and 1 are the same thing. And let's say we took the limit of this as n approaches infinity, because we want to know what the value we'll be adding is when we hit infinity. You would get 1 over 2 to the infinity power, which is 1 over infinity, which equals 0. And so we know that eventually you're going to get to a point where it's so insignificant that you're basically adding 0 to it. And that is part of the reason that we know this is going to converge, is because eventually we'll be adding 0. The nth series test is basically saying that if you take a limit of your series right here to infinity, and it equals something that is not 0, then it must diverge. So, for example, in this exact one, to take n to the infinity power, or sorry, n to the infinity n over 2n plus 1, you would get 1/2. Remember from the very first unit of this year, you would just use the leading coefficients? So you get 1/2. That means when you get to the infinity power, as in, like, this series is taken to infinity, you're still going to be adding 1/2. Therefore, this can't converge because even taken to infinity, it's not small enough for it to be 0. So therefore, this diverges by the nth term test. And to notate this one correctly, you would say that series diverges by nth term test. And by nth term test, I mean nth term, I hope you can see this, I know the glare's back, test, like that. Now, one thing I need to argue is that the nth term test tests for divergence, meaning that you can test this and say this diverges because of the nth term test. You can never say something converges by the nth term test, aka you can't get the limit to equal 0 and then say it converges. No, that's not enough information, unfortunately, because there's so many other factors for convergence, but it's just a way of knowing divergence. Okay, that is the nth term test. The next thing is the easiest one, I think, because it's the harmonic series. And what's cool about the harmonic series is it's not a type of equation, it's literally one exact equation, if you get this one. One over n. Now, granted, you can have the bottom one starting at different values. The bottom one starts at 1, 2. It will make a difference. This will always, always diverge. It's called the harmonic series. And this is an exact example of when the nth term test would not work, because if you took the limit as n approaches infinity of 1 over n, you would get 0. But this actually diverges. Diverges by harmonic series. Now, I believe next video we're going to talk about p-series, and I'm going to show you why this diverges. I might not prove it to you, but I'll tell you another way you know this diverges. But basically, you just need to know that 1 over n is the harmonic series, and it always diverges. Okay, the next last one I'm going to talk about in this video is the telescoping series. Now, an example of this one is this. N equals, this is starting at 1 to infinity of 1 over n squared plus 2n. Now, I'm going to kind of skip the work on this one because it's going to take a while, and I don't know why. It's going to be dark for a second. I don't know why I'm doing this without that, because now you don't see the glare. Sorry. This series right here is a pain in the butt. It's called the telescoping series, and this is basically partial fractions, as we did 2 units ago. You gotta bring them back. So, what you're gonna do in this one is notice that the denominator factors, and you get n equals 1 to infinity of 1 over, or of something, a over n plus b over n plus 2. Then we're going to do what we did in the other, when we did the other fractions, and you'll do a n plus 2 plus b n equals n squared plus 2n, and you can solve for a and b. You would get that a, in this case, you would get that, just to save some time and some work, if you want to know how to do this, go back to the integration of partial fractions from 2 units ago, but you would get that a equals 1/2 and b equals -1/2. Now, for right now, that's all you need to know. What's cool about this series is that for the telescoping series, if your a and b values are opposites of each other, for example, if you get a is 2 and b is -2, if you get a is 1/3 and b is -1/3, if they're opposite of each other, the series converges. You could just say right here, if the question just asks does it converge or diverge, you'd say converges telescoping series. That's it. But because we are intellectual students, it's time to now think, what does it converge to? So, if the question asks what does it converge to, all you have to do is think, well, I'm going to pull out because you can pull out constants, I'm going to pull out the 1/2 from my series after plugging in the a and b, and say that 1 over n minus 1 over n plus 2. Because think about it, if you multiply the 1/2s in, that would be what our a and b values would give us. And now it's just time to write a few values out. So we'll get 1/2, I'm on my knees, 1 over 1, which is 1, minus 1 over 1 plus 3, or 1 plus 2, which is 3, plus 1/2, minus 1/4, plus 1/3, minus 1/5, plus da-da-da. But do you notice something? These cancel out. And as you went on, you'd get a plus 1/4, plus 1/5. That means these are going to cancel out, these are going to cancel out. So you're left with a 1 and a 1/2. So therefore, you get 1/2 on the outside times 1/2 plus 1 plus 1/2, which would be 3/2, which equals 3 over 4. And that is what your telescoping series will converge to. So, that right there, this video talks about nth term test, we talked about the harmonic series, and we talked about telescoping series and how to find what they converge to.